Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths Practice Questions on different types of graph. If you need any extra help on the types of graphs, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video number 346A, there's a dedicated video tutorial there on different types of graph. Alternatively, you can scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, let's have a look at our first question, question number 1. So question number 1 says, shown below is a sketch of a graph. So we've got the sketch of this graph here, and we've been asked to circle the possible equation of this graph. So if we have a look at it, it's an n-shaped parabola, and you should know from your quadratic graphs that if you've got a u-shaped parabola, that's an x squared graph, and if you've got an n-shaped parabola, it's a negative x squared graph. So let's have a look at our options. We've got y equals x cubed. Well, no, that's going to look like this. If we had an x cubed graph, it would look something like that. Y equals negative x cubed would look like that. So similar to this one, but a reflection in the x-axis, or flipped upside down. Y equals negative x squared, so that's the graph we're looking for there. Y equals negative x squared, because that is our upside down parabola, our n-shaped parabola, like so. And then here we've got our y equals x squared graph. Well, that would look something like that, and that's not the graph we've been given. So the possible equation of this graph here would be y equals negative x squared, and that's it. Okay, let's have a look at our next question, question number 2. So question number 2 says, shown below is a sketch of a graph. So we've got another sketch of a graph. If we go back up here, we can actually see it's the y equals x cubed graph. It comes up, passes through the origin, and then goes up again, like so. And we've been asked to circle the possible equation of this graph. So again, we had our, if we go back up here to these options, we have our x cubed graph, looks something like that. Our negative x cubed graph would be the same, but the other way around, so that's not that option. And then we have got our two quadratic graphs, those parabolas, the n-shaped one and the u-shaped one. So our answer is going to be that one there, y equals x cubed. That's the y equals x cubed graph. And again, if you can't remember that, well, you should really for GCSE maths. But if you can't remember that, you can actually just do a little xy table and just choose some values of x and y. So you could start off with perhaps negative 2, and negative 2 times negative 2 times negative 2 is negative 8. So it might be negative 2, negative 8 down there somewhere. Negative 1, well, negative 1 cubed is negative 1, so it'd be maybe there somewhere. So that's negative 1. 0 cubed is 0, so that's in the origin. 1 cubed is 1, so that's going to be the point there, and then 2, 8 would be up there somewhere, and then you can just double check that that answer makes sense. And if you were to do the other ones, you'd find out that those points would lie on a curve that looks like that. But again, really for GCSE maths, you should know the shapes of those four graphs. Okay, let's have a look at our next question, question number 3. So question number 3 says, shown below are the sketches of four graphs. So we've got graph 1, that looks like y equals x cubed. We've got this graph here, graph 2. Well, that's a straight line graph that passes through the origin. So it could be a graph such as y equals x, or y equals 2x, or y equals 5x, or y equals a half x, or something like that. Then if we go on down, we've got a parabola that passes through the origin. It's a u-shaped parabola, so it's going to be the graph in the form of y equals x squared. And then we've got a straight line graph that passes through the origin, but it's coming down this way. So the equation of this graph could be something like y equals negative x, or y equals negative 2x, or something like that. Okay, and then if we go down, part A says, write down which graph could be the sketch of y equals negative 2x. So because it's just negative 2x, it's going to be a straight line graph because it's just x, and it's negative 2 is the gradient, so it's going to be coming down that way. So that's going to be this graph here, graph 4. Okay, because it's got a negative gradient and it's a straight line graph, so it's going to look like that. And now our next one, part B. Part B says, write down which graph could have a sketch of y equals x squared. So x squared, that's going to be u-shaped parabola. So u-shaped parabola would be graph 3 here. So graph 3 is the y equals x squared graph, the quadratic graph. Okay, part C. Part C says, which graph could be the sketch of y equals x cubed? So remember, the x cubed graph would look like this. It would come up and then flatten it up again, like so. So that would be graph number 1. So that'd be graph number 1. And that's it. And that's it. So A would be graph 4, B would be graph 3, and C would be graph 1. Okay, let's look at our next question, question number 4. So question number 4, we've been asked to sketch the graph of y equals x squared. So that's a quadratic, and it's a positive quadratic, so it's going to be a u-shaped parabola. And it's just y equals x squared, so it's going to pass through the origin. So it's going to look something like this. And that's it. That's my sketch of y equals x squared. So it's that u-shaped parabola that passes through the origin. And that's the best I can do here on the computer. Okay, let's have a look at our next question, question number 5. Okay, so question number 5, we've been asked to sketch the graph of y equals 1 over x. So that's the reciprocal graph, y equals 1 over x. And if you need any extra help on this graph, y equals 1 over x, feel free to go to Corbettmaths and watch the video on reciprocal graphs, and that'll be useful for you. So reciprocal graphs will look like this, where you've got your x-axis and y-axis. You will have a section here on the right-hand side of the y-axis that will look like that. And then on the left-hand side of the x-axis, you'll have a section that looks like that. And the reason is, if you do 1 divided by a very small decimal number, such as 0.1, 1 divided by 0.1 is 10, so it's up very high. And then as you do like 1 divided by 0.5, that's equal to 2, so it's coming down. 1 divided by 1 is equal to 1. 1 divided by 2 is equal to 0.5. 1 divided by 10 is 0.1, and so on. And then it'll never reach the x-axis, because even if you divide by a million, 1 divided by a million is still something. So the graph would look like that on the right-hand side of the y-axis. On the left-hand side, remember, a positive divided by a negative is a negative, so it's going to be down here. And the graph would have that shape there. So the sketch of the graph y equals 1 over x would be something like this. And that's it. That's my sketch. That's the sketch of the reciprocal graph. Okay, let's have a look at our next question. Okay, question number 6. So question number 6, it says that a graph has been sketched below. So let's have a look at this sketch here. It looks like the cubic graph, the graph of y equals x cubed. Remember, that looks like this, where it goes up and then flattens out, passes through the origin, and then goes up again. As you can see here, it doesn't actually go through the origin, it's a bit below. So to me, it would be actually something in the form of perhaps y equals x cubed subtract a number, such as subtract 1 or subtract 2 or subtract 3 or something like that, where all the heights have come down 1 or come down 2 or come down 3. So it's the whole graph but shifted down some squares. So I think it's going to be in the form of y equals x cubed subtract a number. So let's look for a graph that looks like that in terms of our options. So here we've got y equals x cubed plus 2, so that's going to be this graph but shifted up 2 squares, so it wouldn't look like that, so no, it's not that one. X squared take away 2, y equals x squared take away 2, well, that'll be a u-shaped parabola but shifted down 2 squares, so it's not that one. Y equals x squared plus 2, well, the x squared graph is that u-shaped parabola, but plus 2 would be shifted up 2 squares, so it's not that one. And finally, y equals x cubed take away 2, so that's going to be the x cubed graph, but then subtract 2 means move down 2 squares, so it would be this one here. So that's it, that's the correct option there. So our guess of y equals x cubed take away 1 was close, it was actually take away 2. Okay, let's have a look at our next question, question number 7. Okay, question number 7. This is an exponential graph. So feel free to go to Corbettmaths and watch the video on exponential graphs. So they're graphs in the form of y equals a to the power of x, where you've got a certain whole number to a power of x, such as y equals 2 to the power of x. And if you were to consider the graph of y equals 2 to the power of x, well, 2 to the power of 0 would be 1, so that's the point there. 2 to the power of 1 would be 2, so somewhere there, 1 across 2 up. 2 squared would be 4, so 2 across 4 up. 2 cubed would be 8, so 3 across 8 up. And as you can tell, it's getting very big very quickly, so that's why it's very steep here on the right hand side. In terms of the left hand side, when you've got negative powers, such as 2 to the power of negative 1, that's equal to a half. 2 to the power of negative 2 is equal to a quarter, so it comes down and it approaches the x-axis but never reaches it. So this graph here is an exponential graph, so let's look for an equation that looks something like this. So our options are y equals 4 over x, that's a reciprocal graph, we looked at that previously, so it's not that one. Y equals 4 to the power of x, that's perfect, so I think that's going to be our answer. Let's just check some of our options here. Y equals x to the power of 4. Well, if you actually sketch this one and you do a little xy table, you'll find it's a bit like a quadratic graph, but it's even steeper, so it's not going to be that one. And then finally, y equals x over 4. Well, actually, if I write that in a slightly different form, y equals a quarter x, just bringing that divide by 4 in front and writing a quarter x, because obviously multiplying by a quarter is the same as dividing by 4. This is actually a straight line graph with a gradient of 0.25, so that's going to be a straight line graph, so it's not that one. So that's our exponential graph there. We've got y equals 4 to the power of x. So 4 to the power of 0 is equal to 1. Whenever x is equal to 1, 4 to the power of 1 is equal to 4, so 1 across 4 up. 4 to the power of 2, well, 4 squared is 16, so 2 across 16 up, and so on. As you can see, it gets very steep on that right-hand side. And then with the negative powers, 4 to the power of negative 1 is a quarter, and so on. So the graph would look something like that. Okay, let's have a look at our next question. Okay, so let's have a look at our 6 graphs. So graph 1, that's a cubic graph. Graph 2, that's a reciprocal graph. Graph 3 is an exponential graph. Graph 4, that's a quadratic graph. graph 5, that's a straight line graph, y equals mx plus c, or y equals mx in this case. And then here we've got graph 6, which is a negative cubic graph because it's going the other way, like so. And then if we go down, and then we've been asked to match each relationship or equation to the correct graph. So we've got these 3 equations and we need to find their graphs. So we've got y equals negative x cubed. So y equals negative x cubed will look something like this, where it's coming down, and then flatten out and then come down again. So that was graph 6 there, so graph 6. We've got the reciprocal graph, y equals 1 over x. So that was graph 2, the reciprocal graph. So that's graph 2. And then finally, we've got an exponential graph, y equals 3 to the power of x. If we go up, 3 to the power of x would be this one, the exponential graph here. So that'd be graph 3. So our graphs are 6, 2, and 3. Okay, let's look at our next question, question number 9. So question number 9 says, show and below is a sketch of a graph. So we've got this graph, and then if we go on down, we've been asked to circle the possible equation of this graph. So which one of these 4 equations is the equation of this graph? So we've got y equals 1 over x. That's the reciprocal graph. That's going to look something like that. So it's a reciprocal graph, so it's not that one. We've got y equals sine x and y equals cos x, and this is one of those graphs. This is a trig graph, and if you've covered trigonometric graphs, you'll recognize this as one of those trigonometric graphs, and we'll come back to these two in a second. And finally, this one here is an exponential graph. So an exponential graph would look something like this, where it goes up, passes through the point 0,1 and goes up like so. So it's not going to be that graph. Okay, so we've got 2 options here, y equals sine x or y equals cos x. Now the graph of y equals sine x, and this is a calculator question here, so you could use your calculator to check it. If you do the sine of 0, you get that's equal to 0. So the sine graph actually passes through the origin. Whereas if you do the cos of 0 degrees, the cos of 0 is equal to 1. So that's the point there, 0, 1. And then if you do the cos of 90 degrees, you get that's equal to 0. The cos of 180 degrees is equal to -1, and so on. So this is the graph of y equals cos x. And it's very useful to know what the graphs of the trigonometric functions look like, to know what the graph of y equals sine x looks like. So it passes through the origin, and then you've got that sine wave. You've got the cosine wave, it starts at the point 0,1 and then carries on like so. And just make sure you know what those look like, and also the tangent graph as well. Okay, if we carry on then. So question number 10, we've been asked to sketch the graph of y equals sine x, so the sine graph, for values of x from 0 to 360 degrees. So it's a calculator question, so you can type these into your calculator. The sine of 0 is equal to 0. The sine of 90 degrees is equal to 1. The sine of 180 degrees is equal to 0. The sine of 270 degrees is equal to -1. The sine of 360 degrees is equal to 0, and so on. Or you could learn where those key points are, and I would actually recommend that to my students, to learn those key points on the sine graph. And then in terms of the curve, let's draw it. And that's it. That's my sketch of y equals sine x, and that's the best I could do on the computer there. And that's it. Okay, so that's question number 10. And let's have a look at our next question, question number 11. Okay, let's have a look at our next question, question number 11. So question number 11, we've been asked to sketch the graph of y equals 2 to the power of -x, and we've been asked to label the coordinates of any points of intersection with the axes. Well, there's going to be 1. And if we have a look at this, this is an exponential graph, but here, instead of it being to the power of x, it's to the power of -x. So let's see what that would do to this graph. Okay, so let's draw this graph. Now, I actually probably would just draw this straight away because I know what it looks like. And if you know what it looks like, just sketch it. But I'm going to do a little XY table here to help explain why it has this particular shape. So if we have x and y, so if we choose some values of x, -3, -2, -1, 0, 1, 2, and 3. Okay, so let's start off whenever x is equal to -3, so over here somewhere. So if x is equal to -3, we've got 2 to the power of -3. Well, -3 is going to be to the power of 3, so we've got 2 to the power of 3. And 2 to the power of 3 is equal to 8, so it'd be 8. So it's going to be -3 across and 8 up. Whenever x is equal to -2, we're going to have 2 to the power of -2. Well, the -2 is just going to make it 2, so it's going to be 2 squared, which is 4. 2 to the power of -1, well, that's going to be 2 to the power of 1, which is equal to 2. 2 to the power of -0, well, that's just 2 to the power of 0, which is 1. Okay, so let's consider these points to begin with. So -3, 8 is going to be up here somewhere. -2, 4 is going to be up there somewhere. -1, 2 is going to be there. 0, 1. So it's actually the same as the exponential graph that we've looked at so far, but it's coming down the other way. Rather than it going up this way, it's coming down this way. So really what you're going to find here is this graph is a reflection in the y-axis. So rather than the exponential graph going up this way, it's going to be coming down this way. If we had 2 to the power of -1, that's going to be a half, and then a quarter, and then an eighth in terms of the other ones. So it would come down like so. And remember, it never reached the x-axis. And that's it. Oh, and in terms of labeling the point of intersection with the axes, that'll be the point here, 0, 1. And that's it. Okay, let's have a look at our next question, question number 12. Okay, question number 12, we've been asked to sketch the graph of y equals negative 1 over x. So this is the negative reciprocal graph. Okay, so remember the reciprocal graph, the graph of y equals 1 over x looked like this. If we have our x-axis and our y-axis, it looked like this. So that's what the reciprocal graph looks like. In terms of the negative reciprocal graph, well, let's do a little xy table and see what it looks like. Now I know what happens here. I know that it's a reflection of the x-axis, that this part goes down here and this part goes up here. But actually, let's have a look and see why. So let's consider some values of x. So let's choose negative 10, negative 5, negative 2, negative 1, negative 0.5 and negative 0.1 to begin with, to see what happens on the left hand side of the graph. So remember, to find the y coordinate, we're going to do negative 1 over the x coordinate. So 1 divided by negative 10 would be equal to negative 0.1, but it's negative that, so it's going to be equal to 0.1. If x is equal to negative 5, we've got 1 over negative 5, which is negative 0.2, but it's minus that, so it's going to be 0.2. If x is equal to negative 2, 1 divided by negative 2 would be negative 0.5, but negative that would be 0.5. Negative 1, 1 divided by negative 1 is negative 1, but times that by minus 1, or change the sign, would be equal to 1. And then if x is equal to negative 0.5, 1 divided by negative 0.5 is negative 2, but minus that would be 2. And then finally, whenever x is equal to negative 0.1, we find that y is equal to 10. So if we consider these points, negative 10 across, 0.1 up, negative 5 across, 0.2 up, negative 2 across, 0.5 up, negative 1 across, 1 up, negative 0.5, 2 up, negative 0.1, 10 up. So you'd actually find that the graph looks something like that. So it's a reflection in the x-axis. And then likewise, if you were to substitute in positive values of x, and then whenever you do 1 divided by those positive values, and then times it by negative 1, which means change the sign, what's going to happen is it's going to be reflected down here. So it'll look something like that. And that's it. So that's a sketch of y equals negative 1 over x. So rather than the graph being in here and in here, it's reflected. So this goes up there and that goes down there. And that's it. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on types of graph. I really hope you found this video useful. If you have found it useful, please like it and please subscribe to my YouTube channel. Thank you. Cheers. Bye.